Okay, so we're going to prove the isosceles triangle theorem, which states that if two sides of a triangle are congruent, then the angles opposite those sides are congruent. So if we have AB is congruent to AC, then angle B must be congruent to angle C, right? The angles opposite those sides must be congruent. So let's go ahead and start the proof. Okay, so the first thing we're going to do is we're going to drop altitude AD from vertex A. Okay, so let's go ahead and do that really quick. So we'll drop a line. Okay, and it's an altitude, so that means it hits BC at 90 degrees. So it hits that AD hits BC at 90 degrees. This forms two right triangles, right? Triangle ABD and triangle ACD, right? It forms these two right triangles. So what we know about these two right triangles is that AD is congruent to AD, right? And AB is congruent to AC. So from the hypotenuse leg theorem, right, we have a leg congruent to a corresponding leg, and we have the hypotenuse congruent to the other hypotenuse. So that means by the hypotenuse leg theorem that these two triangles here are in fact congruent, right? So we know that the measure of angle BDA is equal to 90, which is equal to the measure of angle CDA, right? BDA is congruent to CDA, right? We have that AD is congruent to AD, right? That leg is congruent to that leg. And we have that AB is congruent to AC, right? And we have AB is congruent to AC. So this means, by the hypotenuse leg theorem, that triangle ABD is congruent to triangle ACD, right? We know that this triangle here is congruent to this triangle here. And if these two triangles are congruent, we know the corresponding angles are congruent. And of course, we know angle B corresponds with angle C. So this implies that angle B is congruent to angle C, which is what we set out to do. We proved that if we have two sides that are congruent, then the opposite angles to those sides are also congruent.